lecture series Programming in C. In this module of the series, we are going to learn about the usage of unions in C. The agenda of this module is we will have introduction to unions, structures versus unions, union declaration, accessing unions, nested unions, and we will also see some use cases on application of unions. Already in the previous sessions we have learned about structures, the usage of structures in C. Unions will be a bit different from structures. So, let us see how unions are able to help us in writing the code in C. Right. So, before learning about unions, let us learn about the advantages of using unions. Memory efficiency. So, unions are primarily used to save memory, especially in memory constrained environments like embedded systems. Say for instance, recent days we are moving or we are making use of smaller electronic devices like Apple watches, Fitbits and Echo systems and Amazon's Echo Dot systems like Alexa and other memory constrained devices. We call these devices as memory constrained devices because the memory is very limited in only megabits. So, what happens if we are trying to use a structure which is of a larger size and which can't be accommodated using the single or simple memory. So, in those cases unions will help us to determine the size of the memory constrained environment and to accommodate the data within the limited memory space. And it is a single active member in the sense that at any particular given time only one member of a union can hold a valid value. It means that when we are trying to store a union in memory, the biggest or the largest member size is being determined or is being assigned for the union. So, let us learn or let us go through again review the usage of structures. In the case of structures, if I am having 3 members, one is of integer type, one is of character type, the other is of float type. So, what happens here? The integer occupies 4 bytes of space, the floating point value occupies 8 bytes of space and the character will occupy 1 byte space. So, altogether we will have the summation of the memory spaces like 4 bytes, 8 bytes and 1 byte. So, put together 13 bytes we require and that would be the size of the structure. Whereas, in the case of unions, the size of the union is determined by the size of its largest member. See, according to the example which we are considering, integer will be of 4 bytes, floating point value will be of 8 bytes and character will be of 1 byte. So, the maximum memory space is occupied by the floating point member. So, then the size of the union will itself be the size of the floating point member, which is going to be 8 bytes. So, that is the reason that at any particular given time only one member of the union can hold a valid value. So, I can use the same memory shared by all the members. Assigning a value to one member overwrites the data stored by the previous member. So, for instance, if I am storing an integer value onto the union's memory and when I am trying to replace it or overwrite it using a floating point value, then the previous value of integer will not exist. So, always there can be only one member which can have the valid value at a particular time. Accessing members, members are accessed using dot operator with a union variable or an arrow operator when we are trying to use pointers to union. So, this process, this accessing member methodology, it is same as the structures. In structure also we can make use of the dot operator using a structure variable and a pointer operator in case if you are using a pointer to a structure. The same way here also we are using 2 operators for accessing the member of a union, right. So, programmer responsibility. So, what is the responsibility of the programmer in this case? The C language does not keep track of which member is currently storing a valid value. This is actually one point to be made serious, and the programmer should take responsibility by tagging an enum or a way of representing or holding which particular member is currently active. So, that has to be kept track by the programmers, because C compiler will not bother about or will not be knowing what particular value is currently being stored and used. So, we have to be very careful on using unions in that case. A union is a user defined data type that can hold different data types similar to structure. Yes, unlike structures, all members of a union are stored in the same memory location. Let us see how actually the memory is behaving in case of unions. Right. Since all members share the same memory, changing the value of one member overrides the value of the others. So, at a particular point there can only be one member which is active. So, the other member's value, whenever it is required, it can be overwritten in the memory, and that could be used whenever it needs to be used, and once if its usage is over, then we can move it or we can replace it with other value, other members value, right. Union members can be accessed using dot operator in the similar way as structures, and in case if you are using pointers, we need to use the special pointer operator. So, here the union variable is named as u here for example, then u dot particular member name can be used. Unions are useful when you want to save memory by storing different types of data in the same memory space. Actually, this is an interesting component, interesting characteristics of union in C language, so that we can use the same memory location, same memory space for handling more type of data which is of different data types. Okay. So, let us see with an example. So, here I am defining a structure EMP which has two members, character and float. We have already learnt that the size of character type is going to be 1 byte and floating point value is going to be of 4 bytes. So, when we try to find the structure of the size of E, which will be 1 plus 4, we are going to add the size of the members to get the actual size of a structure, which will be of 5 bytes, right. Now, learning about unions, union can also be defined in the same way as we declare the structure with the two members char x and y. So, char will be of 1 byte length or size, and the floating point value y will be of 4 byte in size. Okay. Now, here in union we need to find which is the member which will occupy larger space. According to the given example, there are two members of 1 byte and 4 byte space. So, according to this, the member with 4 byte will be chosen as the one with larger storage or one which requires larger storage space. So, what happens, the memory or the size of the union will be allocated with the member size which is of larger size, right. According to the example which we take, y occupies 4 bytes compared to x, 4 byte y space is larger. So, what happens, the size of union will also be of the size of the largest member which is 4 bytes. Okay. So, one point here we have to notice that in the case of using structures, even though there is only 2 members, the size of the structure is 5 bytes, whereas in the case of union it has been now reduced to only 4 bytes, right. Also, we have to notice one more point, that there is a memory sharing being done in unions which is not being done in structures. In structures, if you see, X is stored in one location and Y is stored in another different location. But when we see the union, both the members occupies the same memory space. So, here we can see drastically the memory space requirement has been reduced compared to structures. Yeah. When we see the differences between a structure and a union, most of the time people will get confused with the usage of structure and union, because usage wise it is all the same, because the syntax wise it is all the same, but memory space and usage of memory which will be different compared to the structures and the unions. So, we are here we can say structures are user defined data type that groups different data types into one entity. Unions are also of user defined data type that stores different data types in the same memory location. That is what is a major difference between structure and unions. So, here we use the keyword struct, and unions we define using the keyword union. And size, if you look into the size of structures and unions, sum of size of all the members plus padding if required, it will be the size of the structure variable. Whereas, in the case of union, the size of the largest member plus padding if required. Then memory, see generally we require padding of bits in case if the memory is going to be of fixed size blocks. So, that is a reason that we even add padding details. If you compare the memory, each member gets separate memory in case of structure. In case of unions, all the members will share the same memory. Right. Data overlap, no overlap, members are independent. In the case of union, completely overlapping required, because the same memory is being shared by more than one member. Then how do we access the members? All members can hold values simultaneously. It means that if I am having 4 members in a structure, all the 4 members values can be simultaneously being used in the function or a program. Whereas, in the case of union, only one member will be active with valid value at a particular time. So, it means that whenever we want union to be processed, we need to use one particular member, and after its usage is over, then it has to be overlapped or it has to be rewritten with another member's value. So, that is how a union works. Now, hope we have learnt the difference between structures and unions. What about the similarities between structures and unions? Both are user defined data types used to store data of different types as a single unit, that we have seen. Their members can be of objects of any type, including structures and unions or even arrays. The same way as we have learnt in using structures, here also the members can be of any type. It can be a structure, it can be a member, it can be a union, or it can be an array. A member can also be a bit field. Both structures and unions support only assignment and size of operators. So, this we have to be very careful on using both structures and unions. A structure or a union can be passed by value to functions and written by value by functions. The argument must have the same type as a function parameter. This we have already learnt on structures. The same way the union can also be passed as a value by the concept of call by value. Also, we can make use of pointers to point to the structure variable as union variables. We will be able to even pass the pointer to structure or union as a parameter, that is also possible, right. Dot operator or selection operator, which has one of the highest precedences, which is used for accessing member variables inside both the user defined data types, right. So, we can make use of the dot operator for accessing the members, and it has the highest precedence compared to all other operators. So, that is the reason that we use the dot operator for representing the members of a union or a structure. Right. Now, union declaration, we will now learn in depth about union, practically how we will be able to use it in implementation. Okay. So, union is declared similar to the structures. So, similar to structure, provide the name of the union and define its member variables. So, what I do? I use the keyword union, I use a user defined name, this is a user defined name. It can be defined by the user, which is actually the name of the union. Then we can go ahead with declaring the members with the data type, and similar to structure, end the union with curling braces, closing curling braces and semicolon. Okay. Like structures, union also can be declared in more than one method. So, what are the methods? In type 1, a union named sample with 3 members, an integer a, a floating point value b and a character c. Okay. In type 1, what we do? We are just using the keyword union and a name, user defined name sample, and we are declaring 3 data members, one of integer, float and the other one as character. And here you can see a simple declaration of union variable along with the declaration of union. While declaring the union itself, we can give the name to the union variable. Union variable can also be defined at the time of declaring the union itself. Okay, this is method 1. Method 2, a union with 3 members, the same way can be defined by giving the name S, right. So, what I do? I am declaring 3 members and I am just declaring a, I am just naming the union with the name S. Okay. In the first type, we have used 2 names, sample and S. So, here it is enough that if you name it just by giving a name S, right. The third category will be defining the union named sample with 3 members, and also we can define the variable for union separately by giving a single declaration statement. So, here we can see that this is going to be the union declaration and this is going to be the union variable declaration. So, we have separated these two categories, these two declarations, and this can also serve as for declaring the union type variable. So, this will be the reverse process of the first type. In type 1, along with the declaration of the union, we have given it a name. The third one is we can define the union separately and we can give the name or declare the union variable in a different way or separately. So, when union is declared, compiler allocates memory to hold largest member. So, that is more important to learn. Only one member can be accessed at a time. Okay, these 2 points we have to always keep in mind while learning unions, right. The first point is when union is declared, compiler allocates memory to hold largest member. According to the example which we have assumed, integer, float and character, float occupies the larger memory space. So, whatever be the memory space that is allocated for float will be the size of the union, right. Let us take some examples how to initialize and access the union variables. The same syntax should be used as we do for structures to access the members. We can make use of a dot operator or an arrow operator if it is through a pointer. Okay. So, let us learn both. So, let me take an sample union with 3 members, the same one we have taken as the example when we try to learn about the declaration part, right. Now, in the main code, what I do? I declare a variable of union named S. So, now how I have to access and I have to initialize a value to the structure union member, right. How do I do it? I can just simply use the dot operator to access its members. We have 3 members here A, B and C. So, I need to use it as the union variable S dot A equal to some value we can do. So, this is what initialization of union variable. Right. So, what I can do? I can now, if I have to print and check the value which I have initialized to the union variable, I can make use of the same way I do with the printf statements. So, s dot a is now printed, displayed. Okay. So, this is what accessing the union variable. Right. The same way I can make use of the statement s dot b, I can print it, s dot a I can assign and print it, right. What will happen if I do not use this printf statement, if I do not give this printf statement, what will happen? We are making use of s dot b equal to 10.5 and then I give s dot c equal to a. Now, what happened according to unions concept, the value of s dot b will be overwritten by the value of s dot a. Now, if we are trying to display the value of s dot c, only the value of s dot c will be displayed, we will not be able to get the value of s dot b, because the value of s dot b will be overwritten by the value of s dot c, because the memory can hold only one value at a time. So, we have to remember this concept of unions whenever we use it in the program. The size of the union will always be equal to the size of the largest member of the union. This we have learnt. All the less sized elements can store the data in the same space without any overflow. We will see examples for illustrating that. I use a union with the name A, which has two members x and y of integer and character. I also include one more union B with an array of 10 integer elements and a character, right. In the main program, what I do, I want to find the size of union A and size of union B, right. So, what happens in the first case, union A, I have an integer variable of size 4 bytes and a character variable of size 1 byte. So, this is for integer x and char y, right. So, the largest size is being allocated for integer, which is 4 bytes. So, the size of union A will be 4 bytes, right. When I take the second example, union B has 10 integer elements. So, one integer element occupies 4 bytes. So, if it is going to be 10 integer elements, which is going to occupy 40 bytes, okay. And there is also one more member char y. So, this is ARR of 10, right. So, char y occupies 1 byte, right. So, comparing these two sizes, 40 bytes is the largest size. So, 40 bytes will be the size of union B. So, we can see that the output of size of A is 4 and size of B it is 40, right. Hope now you have understood the way how the memory representation is being done, right. Let us learn how unions memory representation is being carried out. As the same example we have taken for the illustration of sizes, we will also use the same way, same example. Union A occupies, or the size of union A is 4 bytes, which has two members int x and char y, okay. So, int x occupies 4 bytes, whereas char occupies a part of 4 byte, 1 byte is being used by the other member. The same one portion of the one member's memory space is being shared by the other member. In the case of the second example, union B, we are going to, the size of union B is 40 bytes. It means array of 10 elements occupies 40 bytes, out of which one member of character type will occupy 1 byte. So, here memory is being shared, okay. So, also it is being reduced, the memory space requirement is reduced, right. Union of structures. A structure can be nested inside a union, also a union can be nested inside a structure, okay, vice versa we will be able to use. So, to define a structure we use a struct statement. In a union of structure we will be having the change in the value of the individual data member which does not affect the other data member of the structure, right. So, let us learn the first case, structure inside a union, which is actually named as union of structures. So, the same way we can make use of the keyword union and a name data. So, here we can see an interesting thing that the members of the union itself can be a structure variable, but see to that the structure which is having the largest size will be the size of the union, right. In the first case you can see the first structure member EMP, it is of integer and float type. So, integer is going to be 4 bytes and float is going to be of 8 bytes. So, 8 bytes will be the size of EMP, and the second one we can see roll number of integer 4 bytes and character 1 byte. So, the size of student will be of 4 bytes. So, out of these two the member which occupies largest memory space will be EMP. So, EMP size will be the size of the union, but here we can see an interesting concept that employees entity is different and student entity is different, but then we can make use of the same memory space for handling more than one entity, which is actually being a interesting concept of using unions in C, right. The second category is union inside a structure. So, first thing we have to use the keyword struct and define the structure using the same keyword, and here you can see one interesting thing that one member of that structure is going to be a union, right. Already we have learnt that in case of union the memory will be shared among the members. Yes, of course, this union will have the concept of memory sharing among the union members, okay. But then the structure's memory will be different for different members, or the location, the memory location will be separate for each member. Say for instance, the type will be assigned with a particular location and this complete union will be assigned with another location, right. So, this is what is the interesting concept of combining union and structure. So, let us see the demonstration of union within a structure and structure within a union examples. Okay. So, here we can see I am defining a structure named X with 2 members and we are defining a union named Z. So, here we can see that one of the member of that union is going to be the structure. So, the concept of structure within union, right. So, here we can see in that case we need to define a union variable in the main program and then using the union variable also using the structure variable we need to access the member. So, here we will be using 2 dot operators, one for union, one for structure, the other for the member of the structure. Okay. So, we can continuously use the dot operator to represent the nesting process of the union and the structure. In order to make you understand in an easier way, the union is named as U and the structure is named as S. So, we can see that U dot S dot A will be having a value which will be accessible. So, the output can be displayed as a member's value, right. And nested unions. So, what if a union can be even a member of another union. So, we can define a union inside another member like structure. So, this is called nested union. The same way we will be able to make use of declare union named student and that student can be a member of another union. Okay. So, here we can see one of the member of that student will again be a union variable, right. Then anonymous union. What is anonymous union? Sometimes C compiler will even allow us to define the union without giving any name to the union. We need not even give a name to the union. Directly we can declare a variable of the union and we can make use of it. This we have seen as a type 2 in declaration. So, here we can see that the union name is not given, whereas union variable is declared and that union variable can directly be used in the program. So, this concept is called anonymous union. Okay, we will take some real world example of a motorcycle. There is a two-wheeler dealership that has both bicycles and motorcycles. While a motorcycle might have attributes like engine size and mileage, and a bicycle might not have the attributes and it can have only the attributes like color. However, both might have a price attribute. So, using unions, the memory space for these attributes can be optimized. So, how that could be done? So, we are defining a structure for motorcycle and a structure for cycle using a union. Okay. Anyway, both these structures are not going to be simultaneously used. So, any one can be used. So, in this case the memory can be reduced and optimized in this case. There are other use cases that the union can be applied, say as we have already seen the memory constraint systems where the memory is limited, unions are very advantageous. In hardware mapping, flexible data interpretation and tagged unions concepts can be applied. So, summarizing on this particular module, we have learnt on structures versus union, how to declare unions, how to access and assign and initialize unions. Also, we have seen structure within unions and unions within structures and nested unions and various use cases and the illustrations. Thank you so much for listening to this session and getting benefited out of learning unions.